Okay, in this video, the moment you've been waiting for, we're going to make the connection to trigonometry. So last video we learned about the wrapping function. And the wrapping function, you plug in an angle. Come on, dude. The wrapping function, you plug in an angle and you get out an x and y coordinate. So if you're looking at that, here's my unit circle. There's the angle, and there's my x and y coordinate, and we observed that it comes from the triangle pieces, right? That's x and that's y. The lengths of the triangles, the sides of the triangles, give us those coordinates. So we learned about the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. And we have to memorize those values, and we use them to find these coordinates. Okay, so the connection now is, there's a lot of ways to remember it, but this can be helpful if you spell it correctly. SOHCAHTOA tells us the relationship between sine, cosine, and tangent, which are all just basically ratios of certain sides of a right triangle. So if I'm looking at a right triangle, and this is my angle that I'm looking from, because it matters what angle you're looking from, then sine of an angle is always equal to, the O stands for opposite side, or opposite leg, and the H stands for hypotenuse. So the hypotenuse would be right here. This is the opposite leg from theta. This is the adjacent leg from theta. Okay, so in this case, sine of theta would be equal to O over H, because that's the side opposite theta, and this is the hypotenuse. Now, if I had, say, alpha here, then sine of alpha, sine of alpha would be, now the opposite side is A, isn't it? And hypotenuse, of course, is still hypotenuse. So the opposite adjacent thing has to do with, in reference to the angle you're looking at. Okay, so sine is opposite leg over hypotenuse. Cosine of alpha, of theta, is adjacent leg over hypotenuse. And then tangent is opposite leg over adjacent leg. So if I'm looking at a triangle like this, that's theta, and that's 3, and that's 4, and that's 5, then sine of theta would be equal to opposite over hypotenuse. Cosine of theta would be equal to adjacent over hypotenuse. And tangent of theta would be equal to opposite over adjacent. Isn't that fun? And likewise, if this would have been a beta up here, then sine of beta, notice now 4 is the opposite and 5 is still hypotenuse. So notice that's the same as that, isn't it? That's interesting. Likewise, cosine of beta would be 3 over 5, because now 3 is adjacent. And tangent of beta, of course, would just be 4 over 3, because the opposite and adjacent are flipped. So this is another thing that you should commit to remember if you don't already know. The SOHCAHTOA could help if you spell it correctly. But somehow you got to get in your mind that the sine of an angle is equal to the leg opposite the angle divided by the hypotenuse of the triangle. So how does that tie us back in the unit circle? Well, if you think about the wrapping function once again, so we got this unit circle, we got the x and y axis, and we got some angle sitting here, and we got a triangle. Well, if that's my angle, and notice the wrapping function, and say that's x and that's y. So the wrapping function of theta is equal to x comma y. Notice that in this drawing, because that's 1, we know that sine of theta is equal to y over 1, isn't it? Which of course is just y. And cosine of theta is equal to the adjacent, which would be x over 1, which of course is just x. So in the wrapping function that you guys have spent some time getting better and better at, the x-coordinate that you get from the wrapping function is going to be your cosine value, and the y-coordinate that you get from the wrapping function is going to be your sine value. And, for that matter, tangent is going to be your y value over your x value. Or, if we make the immediate connection, that would be sine over cosine, wouldn't it? So that tells us that tangent is equal to sine over cosine. So this is really what you need to do, and this is where you want to commit yourself to the next week. If you ask yourself, how do I spend my time for the next week for this class? You've got to get better and better at this that I'm about to show you. So if I ask you what's the sine of 45 degrees, you should be able to, off the top of your head, without looking at a pre-drawn chart or looking at a book or looking at your notes, you should be able to do a quick little sketch maybe, or maybe off the top of your head. Draw a little line, that's where 45 degrees is. Recognize it as a 45, 45, 90 right triangle. And we're looking for the second one, this guy over here. So that would be 1 over rad 2. Or if I said, what's cosine of, say, 120 degrees? Okay, draw my little circle. Doom, doom. 120 would be 30 past 90, so that'd be right here, right? That's a 30-60-90 triangle. It's a standing up 30-60 triangle. So this is my 60-degree angle. So that would be rad 3 over 2. That would be 1/2. And there's my 1, right? So in this case, cosine is the x-coordinate. So I'm looking for that value right there, which would be the 1/2. But since I'm going to the left, that would be a negative 1/2. Okay. Or I could ask you to find sine of 3 pi over 4. Again, I draw a quick circle and realize that 3 pi over 4 would be right about there. Yeah? Because this is 1 pi over 4, 2 pi over 4, 3 pi over 4. And then, again, that's a 45, 45, 90. So I know they're both 1 over rad 2. So I know the answer has to be 1 over rad 2. But sine is the y-coordinate, and that's going to be positive because it's going up. So it's positive 1 over rad 2. Notice if I would have said cosine of 3 pi over 4, I would have got negative 1 over rad 2 because I'm going to the left. Okay, or I could say what's sine of 9 pi over 4. Whoa, that's big. So 9 pi over 4, well, we know that 8 pi over 4 would be one complete circle because that's 2 pi. So I'm sitting right there. So 9 pi over 4 would be 1 more pi over 4. So that's the same as pi over 4, isn't it? It's a coterminal angle with pi over 4. So that means we would have, 1 over rad 2. So the key here is just trying to figure out, once you get an angle, trying to figure out which special triangle I'm dealing with, the 30, 60, 90 or the 45 degree angle, 45, 45, 90, and then pick the right coordinate. And that figuring out which triangle it goes with, that's the idea of that is called the reference angle. This is an important concept, reference angle. So if you're looking for a reference angle, that means when I say sine of 7 pi over 6, so I run around the circle, and 7 pi over 6, of course, is right here. It's that angle. But the angle that I actually use to find the sine value is the angle that's in this little triangle here that I draw, right? So the actual reference angle for this is 30 degrees, or actually, since I'm in radians, I should do radians. The actual reference angle is pi over 6, isn't it? In other words, pi over 6 is the angle of the triangle that I'm using to find the values. So the sine value of 7 pi over 6 would be this value right here, because sine is y. That's the opposite side of this angle. And it's the short side because we have pi over 6 there, right? So that would be 1/2. And it's going down, so it must be negative 1/2. Do a couple more examples. If I have tangent, since we haven't mentioned tangent yet, tangent of 11 pi over 6. Okay. So draw my quick circle, 11 pi over 6. I know that 12 pi over 6 is right here. So 11 pi over 6 would be 1 back. So my reference angle is pi over 6, isn't it? So that's a 30-69 triangle, a laying down one. Since tangent's looking for both, so I'm going to go ahead and get both coordinates for the wrapping function. Let's see, that would be rad 3 over 2 would be the x-coordinate, and negative 1/2 would be the y-coordinate. So over here, I'm going to put y on top, negative 1/2, and rad 3 over 2 on the bottom. Of course, we'd never leave it like that. We'd want to simplify it. So the 2's will cancel out, so I'm left with negative 1 over rad 3. Okay? So your goal is to be able to, in fact, my face-to-face class this Thursday has to pass a quiz where I'm going to give them 10 sine and cosine and tangent questions like the ones we were just doing, like it might say sine of 45 degrees and cosine of 315 degrees and sine of 5 pi over 3, etc. So there will be 10 of those, and they're going to be able, off the top of their head, without looking at any notes or any calculator or anything like that, be able to give the value. So in this case, it would be 1 over rad 2. In this case, it would be 1 over rad 2. In this case, it would be negative rad 3 over 2. Okay? So that's the idea. And about that quick. You might draw a little circle just to help yourself, right? Like here, you draw a circle. 315 is right there, so that's how I knew it was 1 over rad 2, and it's going in the positive direction for x values. Here, 5 pi over 3, that's the same thing as 10 pi over 6, which would put you right here, because it's 2 pi over 6 back from the full circle. And that is reference angle 60 degrees, so the sine is the bigger one, and it's negative, so it'd be negative rad 3 over 2. Okay, so you want to be practicing that. There's no, for the online folks, there's no real way for me to test whether you've got that down or not, but I'm telling you right now, you should have it ready you should be able to do that by Thursday, be able to cruise through, and I'm going to be posting some practice quizzes with answers, so you could definitely download them and try them, maybe give yourself a time limit and see how quick you can do it, and then check your answers. But definitely you want to do that. Because the better you know these, the better the rest of the quarter is going to go. All right.